All right, hello everyone, this is Mr. Crozier. I'm going to go over our review sheet, practice quiz number 1 with some help for that. All right, on the first problem, you are going to answer a bunch of questions and you're going to do everything graphically, so we're just estimating here. Letter A, 1. What is f of 1? Well, that means what's the output? It's about negative 1.5. What's the slope? I drew this tangent. It goes down about 3 over 2. F of 8 is 0. The slope there is going up. So I have a positive slope. I went ahead and drew a secant through the points from that point to that point, and I have this secant line that cuts it. The rate of change between those is up 1 over 3, just estimated. And the last one, part C, which is the mean value theorem here. Find the values where find any x values such that f prime of x equals the slope. So if I draw this tangent here, at this value right here, which is about 4.6, at this point on the line, these two tangents are parallel. That's the mean value theorem. All right, now when we get to problem number 2, we're going to do the exact same steps with this function now, so we can figure out what the exact answers are. The exact answer, if I plug in 1 here, is negative 7/4. And look what it is over here. We got the same thing. The exact slope, if I take the derivative, here's the function, there's its derivative, is negative 3/2. I got it. If I plug in 8 to the original, it is 0. And if I do f prime of 8, well, the exact value is 2. I set up 3/2, very similar. All right, what is the exact slope of the secant? Well, if you do the points 1 to 8 and you find the slope between them using y2 minus y1 over x2 minus x1, well, you figure it out and you do the computation as 1/4. I said it was 1/3. It's exactly 1/4. And this last one, part C, if you do the math here and you get the slope right, on part C, you set the derivative, which is x divided by 2 minus 2, equal to the actual slope, which is 1/4, and do the math, you get 9/2, which is 4.5. So you see how everything comes out very closely. All of the answers on 2 are just like the answers on 1. Very close. These are the exact, these are the estimated. All right, on number 3, it was 9/2 here. I took the derivative, set the derivative equal to 0, and I got these key points, negative 3, 0, 3. And then I tested them out by plugging in any number between the intervals into the derivative, and you'll see it goes down, up, down, up. And if you were to graph this, you'd also see the same thing. All right, on number 4, find any relative extrema. Well, that means you're going to have to take the derivative, and you're going to look on here and say, where is this derivative 0? You got to check the numerator. Can the numerator be 0? No. Can the denominator be 0? Yes. If I put a 6 in there, it is a 0. So putting a 6 in is an undefined answer. That's a critical point. Well, if you draw the arrows, it goes down, touches, and goes back up. There's a relative minimum there. All right, on problem number 5. Again, it's a mean value theorem. It means I have a curve with a secant, and I need to find the point of the tangent. Well, set the derivative. The derivative is here. Set the derivative equal to the slope. Do the computation, and you will find that that point is 1. C is equal to 1 right there. Well, at 1, the y-coordinate is 1/2, so you have to find the whole point. A lot of times we just stop at 1. When we did the first page here, we just stopped at the x-coordinate, but this calls for the entire point. So we went the x and the y value. All right, number 6 is just a mean value theorem problem. We have the height of an object. and it goes from 0 to 5, and it goes down 125 and 5, so it's going down negative 25. The question is, well, when is the derivative equal to that? Well, set that equal to the derivative, 2.5 seconds. 2.5 seconds is a time in between there. It doesn't always have to be right in the middle of it. It wasn't in the middle up here. It's in the exact middle here. At this point in time, that's the speed. Derivative. When do we have critical points? Well, the easy version is what numbers make the numerator 0, what numbers make the denominator 0. So, set the numerator equal to 0. Set the denominator equal to 0, and those are all your critical points. If you were doing a graph of this, if you were doing a first derivative test, these would be your boundary points. Those would be the points that you had to test. When's the numerator 0? When is the denominator 0? Same thing here. We're going from 0 to pi, 0 to pi. And what we're going to do is we're going to take the derivative here, which would be 2 sine x cosine, because that's the chain rule. And the derivative of cosine is negative sine. Factor out a sine, split both of them up, and then you have one critical point, just pi over 3. It goes up and down by testing it. Number 9 and number 6, these are the exact same problem. This problem has math language in it. This problem has a story problem in it, but these are the exact same problems. Find the slope. Here's our slope, 1/2. Set the slope equal to the derivative and solve. And in this case, it's going to require the quadratic formula. Relative extrema. One thing to do here. We go ahead and find the critical points. When is this derivative equal to 0? Well, I go ahead and I find the derivative, and here I took when is the top equal to 0. At the number e, it's 0. When's the bottom 0? 0. And we went ahead and we stopped this at 0 because you can't take the natural log of a negative number, so don't have to worry about 0. And then you'll see it goes up and down. The point is at e, and if I input e back into here, I have 1 over e. So there is a maximum there. On the back, we have this one story problem. We're going to answer a lot of questions about it. The amount of bacteria in a culture is given by this function right here, from 0 to 5. All right, what is the greatest number of bacteria present? Well, 0 to 5 and any critical points. That's what we're doing. I got this number here, 15.8, but again, that's in thousands, so it's 15,833 bacteria. Remember to put units on all of these. Letter B, after how many hours is the least? Well, at 3.5 we have the least. This bacteria it's at 10, it goes up to 13, down to 7, and back up to 15. There's some points on this. It's 10, 13, 7, 15. That's what the bacteria is doing. It goes up, it loses something, and goes back up. When is it decreasing? Well, that middle interval from 1 to 3.5 hours. What is the average rate of change? Well, that is slope. So I find the slope. 5 minus 2 over f of 5, f of 2, and I get 1.5, which is 1,500. What is the instantaneous rate of change after 4.25 hours? Well, you just take the derivative and plug in 4, and you get 4,875. On number 12, it's a bit of working backwards here. We have this point that satisfies the mean value theorem. So we have an answer. We know what the answer is, 4. But we don't know what the interval is. So take a look at what I did here. I still have to do this mean value theorem right there. And that's the key right here. This is what we are doing. We're doing the mean value. We're letting the slope be the value at 4, because I know the answer is 4. So if I take the derivative, which is 2x minus 8, and I plug in 4, I get a 0. So I know at that point the slope is 0. So now I want this slope to be 0. Well, what is the slope? Well, it's y2 minus y1, x2 minus x1. But you're used to having a number there, but you don't. You have a letter. So here's my equation. I solve it, cross multiply. The numbers are 2 and 6. 2's being used. This is a b. It turns into 6. And the last one, critical numbers. Well, take the derivative. Once I take the derivative, there's a critical number. 0, if I put a 0 there, it is undefined. Now, remember what we have to do. We have to check numerators for zeros, denominators. I've checked the denominator. 0 makes that 0. Now I'm going to just go ahead and solve it, add this over, cross multiply, and x is equal to 1. And I've checked both of them. All right, hope this helps with your quiz over 3.1 to 3.3.